So we're going to look at graphing different types of relationships. We're going to look at linear relationships and nonlinear relationships. So often in an application setting, we are dealing with quantities that are related to each other. So for example, voltage depends on current and resistance. The pressure of a gas depends on temperature and the volume of a container. Horsepower of an engine depends on torque and engine speed. So we have all these relationships happening, and certainly a lot of the times we can mathematically model those types of relationships. So if we have a specific equation for a relationship, we can use the table of values strategy that we talked about to create that graphical representation. We can visualize what it looks like, and it helps us make any kind of predictions or models of the type of relationships that we care about. So the following equations, the first thing we're going to take a look at is linear equations, because the graph of these types are a straight line. So for example, y is equal to 2x plus 1 would be a linear equation. Y is equal to negative 3x minus 2 is a linear equation. And then you might not see it with the x and the y's. You might see it with different variables depending on the application. So p is equal to 0.52 times d plus 14.7 is actually a linear relationship. You can think of the p as the y and the d as the x. But in sort of the real situation, your pounds per square inch on a submerged body at a depth of d feet is modeled by that equation. So in general, if we are looking at linear relationships, you may or may not have seen this in some capacity before, that the general form of an equation of a line is given as y equals mx plus b. M we actually call the slope, it's a constant. B we call the y-intercept, that's a constant. And if it's in this format, it's actually a linear relationship, and we will see a linear graph coming out of it. But we are not only going to just see linear relationships. So if it's not of this form or doesn't look like that relationship, we can still do the same strategy. We can create a table of values. We can graph it on our Cartesian plane, but we might get a different type of shape. So it'll be some kind of curve, not a straight line. And depending on the relationship, we may or may not have to go a little bit further with our table of values. So it might take additional points in the table to determine our trend and our shape of our curve. So whether that looks like an exponential function, or whether that looks like a parabola, if you've seen that in the past, then again, we may or may not have to go a little bit further with our table of values to actually get a real picture of what it actually looks like.